area up at Lawrence Berkeley National Labs. She's internationally known for kind of her expertise in sustainable water management and really focuses a lot on the water, energy, food nexus. She's been, has a lot of expertise and shares that expertise by serving in a number of both state and national panels, really advising on the uses of data and really looking at kind of the human and policy implications of data as applied to water, to energy, to wildfire. So I'm happy to invite her or to have her start and introduce the rest of our panelists. So give her a round of applause.
Thank you. Thank you, Sarah. I appreciate that. Hi, everyone. Happy Climate Week, I guess. It's wonderful to be here. I actually had not been to this building. This is beautiful and really impressed by all the discussions we had this morning. Sorry I missed yesterday, but I heard it was really good. We are going to talk about very practical stuff on wildfire and how we are approaching wildfire. It is known to all of us now that we are experiencing more severe wildfires, and they are getting closer and closer to urban areas, and that's why we hear more about them, because when these wildfires are definitely becoming more severe, more frequent, and that is actually a big problem, because when it comes close to urban areas, we are losing a lot of resources, homes, people, lives, and infrastructure. That is actually a big problem. And while often we think about these as, oh, it's all about climate, and that's what's causing a lot of this to happen, it is important to realize some of this, and actually most of it, is driven by some of the policies we have in place when it comes to land use management, fire management, and some of the policies that we have that's related to managing forest. So, and when we don't do the right things, eventually things come into collide, and that is where we are right now, especially because a lot of our people are moving more and closer to wildland areas, the urban areas, and we have a lot of policies around fire suppression and not necessarily doing some of the land management that was practiced for many centuries by native communities, making sure that we burn the land before it basically has so much fuel that it can explode. And land use policies are not really helpful, because we are letting people to build in so many different areas where they shouldn't, and that means that they are putting themselves in the harm ways, and we collectively have to be mindful of how these lands are protected and how fire is or the land is managed to prevent some of these major wildfires. Another problem we have is also how we invest in fire management or land management. And generally, a lot of the time, we spend our money fighting fires rather than preventing them, and that is also a huge issue. Now, we were just actually having this conversation a minute ago, how the landscape has certainly shifted. A lot more discussion happens around wildfires and how they're managed. And I am really delighted to have two experts here who are going to help us better understand how these policies and practices are changing, how we are using data and models to better inform what we are doing, and potentially, gradually, transitioning from constantly spending money fighting fires actually to prevent them. I'm really happy to have you both here. I'm going to introduce them. You'll be as excited as I am for this conversation. Dr. Ilkay Altinas, she is the Chief Data Science Officer at San Diego Supercomputer Center and the Division Director of the Cyber Infrastructure Research, Education, and Development. Dr. Altinas is known for her expertise in scientific workflow, cyber infrastructure, and artificial intelligence methods, particularly in applications such as wildfire management, bioinformatics, and smart cities. She has received several awards, including the 2015 IEEE TCSC Award for Excellence in Scalable Computing for Early Career Researchers, and the 2017 ACM SICPC Emerging Woman Leader in Technical Computing Award. We are glad to have her from San Diego and to help us to explore this topic. And then also with me, I have Dr. Micah Elias. He's the Director of Natural Capital at Blue Forest, where he leads innovation work to scale forest restoration through carbon finance and natural capital investment. His research and leadership aims to monetize the environmental and societal benefits of fire-resilient forest, recently demonstrating that under the right conditions, carbon markets could fully fund wildfire risk reduction. It is important, since we are at Berkeley, I should say, Micah is a graduate of Berkeley. Yes, and I'm sure he's excited to be back on campus. With that, please join me to invite them to this conversation. Okay, let's get into this. I would like to give both of you a chance to talk a little bit about how you come into this discussion. You know, your experience, what you do day to day when it comes to wildfires, and how your organization is participating in this process. Okay, please.
I can start with a personal story that we were just talking about it, which reminded me. In 2003, when we had one of our first, maybe the first wildland-urban interface fire in San Diego, I was in Santa Barbara with colleagues, and I received a message that there's a fire from my husband. And it's like, why is he telling me about fire? What's the big deal? And in the aftermath of it, we had our orange sky in San Diego, and there was hardly any information to be shared and had for the public and for the fire authorities, actually fire management themselves. There were 48 agencies who couldn't communicate with each other and coordinate properly. 2007, we had another one of those large-scale events. So they really created a culture in San Diego. And I've been at the San Diego Supercomputer Center since 2001. I'm a computer scientist, as you heard, with a background in scientific workflows. So I'm sort of the scientist to bring everything together to solve a problem. And, you know, that sort of got us thinking, you know, what can we do? We already had sensors out there, cameras out there at the time through our networking, high-performance wireless research and education network. And we knew there were fire models in the government space, but the science was in the, science space. And tech that we refer to as these models being actionable and things like that was more left to the government at the time. So Wildfire project, or the program now, with 50 people in it, become the first of its example to sort of create a clearinghouse for data, so we can actually communicate that data in a scalable way, in a programmatic way to fire science, and then we can sort of embed those into the solutions. So that's how I got involved in it, and we can also talk about later on how it evolved over time.
Well, first of all, thank you, Nusha, for inviting me. It is fun to be back at Berkeley. While I was working on my PhD, I lived a few blocks from here, and this construction was happening, and traffic was always a mess in front of my house. So it's nice to see that the building looks so nice. My entrance into this space was pretty different. My background is actually in agriculture. I used to work in supply chains. I used to manage farms, and the whole time I was really interested and how we can help support the farmers that are doing the right thing, but are not incentivized by the market. And that brought me into the framework and the space of ecosystem services and being interested in payment for ecosystem services. I used to work, is this still on? I used to work in Central America, and there are some famous water fund projects throughout Latin America, and that was kind of a big inspiration for me. And when I started my PhD at Berkeley, I kind of followed the breadcrumbs into the forestry space. The framework for payment for ecosystem services is easier when it comes to forests and in a defined watershed. And one thing led to, there we go. One thing led to the next, and I started working in forestry and wildfire. And the work that I now lead at Blue Forest is really focused on how we quantify the benefits of preventative forest restoration and how we monetize those benefits to increase funding. So just a little bit about Blue Forest. We're a nonprofit conservation finance organization, and we work to scale ecological restoration primarily to avoid wildfire through science, finance, and collaboration. We originated the Forest Resilience Bond, which does two things primarily. One, quantify and monetize ecosystem services to sort of increase the pot of funding that's available for restoration. And two, provide financing for those projects so they get done more quickly, they're able to be larger, and they're actually cheaper on a per acre basis. Just those overhead administrative costs are spread over more acres. I think what really makes our model unique is our sort of scrappy approach to understanding how benefits manifest across a landscape, understanding who benefits, and thinking through the processes necessary to monetize those benefits.
Thank you. Full disclosure, I'm on the board of the Blue Forest, and I'm a big fan, so I had to mention that. I think both of you highlighted something very important, which is we need to get out of our silos to be able to deal with, for example, wildfire. These different natural hazards are sort of bringing us all together to figure out how our expertise can come to the table and solve this problem. Now, in your perspective, often Teresa was mentioning about too much data, too little data, just in the session before. I do wonder, is this a data problem? Are we missing certain data to be able to do this better? And, what are your thoughts on sort of usability, actionability of the data, and how we can use it better? And also, we had a very interesting discussion when we were preparing for this on data as an enabler versus data as an end goal. So I would love to hear both your perspectives on that. I don't know, Ilkay, do you want to start?
Yeah, data is a scary word for everyone, actually. And if you put science or AI next to it, it's even scarier. Right? And we need to first acknowledge nobody in fire management, land management, utilities are there for the data. They are actually now having to talk about data because we are in this moment in time that data becomes an enabler. And it's required for innovation. It becomes a way to scale things, and it becomes a way to actually collaborate, partner with others. It's a collaborative token. So how do we then enable everyone? This is a cross-sector community, cross-disciplinary community. How do we enable everyone to actually use data and reduce that friction of where data is, how we can access it, how we can use it. And as you said, how can we make it actionable? They are there. If they are talking about data, they're talking about a decision that they need to make based on data. And if they're talking about AI, they're talking about methods to turn lots of data into insights for them, so it makes their job easier. And if they're talking about science, they're talking about it because they're actually trying to understand what's going on better, and we need to make it explainable. So to make things actionable, first of all, we need to make them usable and interoperable with each other. But also, we need to make data timely. It needs to be at the right place at the right time. If it's old data, it's not going to help. If it's too early, it's not going to help. We need to make it interpretable, whoever the decision maker is. We need to be able to navigate from one data to another a lot easier. And we also need to really focus on its trustability and explainability. Right? Why can I trust this data? There's a science process that led to the curation of some. There's other sources of data. So this provenance of data, where it comes from, how it gets to the consumer of it in different contexts is important.
Yeah, I'll highlight what both of you had already said, which is data really needs to be the enabler and not the outcome, especially from a practice standpoint. There's obviously important space to do research for research's sake, but I think when we're trying to affect change, thinking about what the end goal is really, really critical. So when we're working through how best to partner with analytical teams or engage data, our mind is always, how does this connect to policy? How does it connect to end funding sources? What is the end action that we need, and how does this help us get there? I'll highlight one piece of information that I think is really critical, and that is the sort of avoided risk benefits, or the benefits of avoided high severity fire. It's something that's kind of tricky to conceptualize and even harder to put into succinct data forms, but in the ecosystem in which all of us live and throughout California, these are fire-adapted ecosystems. Fire is a natural part of the ecological process. It's an important part of the process. And so it's not a question of if fire comes, but it's a question of when it comes and what it looks like when it comes. It probably isn't gonna come this year, might come in the next 5 years, probably is gonna come in the next 10, but it will definitely come in the next 20. So what does it look like when that fire comes, and how can we tell that story all over a multi-decadal time frame to, let's say, a utility that has a vested financial interest in the green infrastructure that they're surrounded by? How can we tell a compelling multi-decadal story to those entities to drive further investment into the landscape?
That's actually such an important point, and I think one stat that always stays with me when it comes to wildfires is that over this past few wildfires had eliminated some of the work we have done to reduce emissions, almost wiped out some of those efforts. So we are doing all this work to reduce emissions, and then we have one major wildfire, and then there goes half of our efforts, right, or even more. So it's very important to kind of be able to act ahead of time. Doesn't matter when it comes, right? 5 years, 10 years, 20 years, and prevent it rather than just, suppress it for such a long time and let it explode into a great deal.
Just to piggyback on that, the fires in 2020 in California wiped out the emission reduction benefits between 2003, I think it was 2016 or 2019.
Yeah, which is super important, right? Keep in mind, and not even talking about other impacts of it, right? The environmental damage, all the pollution that's causing, and everything else, and air quality and all that. So it is a big problem. Okay, I think you were talking about how you have been involved in this for such a long time, and obviously you are trying to build this data infrastructure that's needed to make better decisions ahead of time. Who is at the table? Who are you making this for? And how do you make sure what you're making is useful by the people who are actually on the ground trying to make a difference?
So I think it wouldn't be wrong if I said everyone is at the table. Who is that everyone? There is the science community, and there is data science community, so more, and technology providers. But there are also practitioners in this area, in fire, land, air management, public health. These are all parts of the problem. Water is a huge part of the fire problem, actually, turns out. And there's also the public, because we cannot do some of the things without the support of public and creating that awareness within the public. So then when you have such a complex cross-sector, disciplinary, and actually cross-expertise level group, how do you bring them together and let them also talk about the nuances of different perspectives and collaborate around it? So it's not easy, but there is a method to madness, actually, I think we're sort of trying to build on. And first of all, it needs to be very use-inspired. And use-inspired, I don't think of it as use-inspired. Yes, the door is use-inspired, and you can do a lot with it. But this is a lot more complex than that, right? what are you building? Is it going to be useful? And it takes a lot of conversation, actually, to understand what is that thing that we need to build that will be useful. And through that, can you actually build some ingredients together so you make that thing usable for whoever needs to use it? And that's more of a university level or partnership level collaboration at that point. But then when you build that usable thing, this is a societal scale innovation. This is not, tech transfer. This is actually something you need to put for use, for scale and sustain at the societal scale in a way that's going to directly affect people. So we sort of came up with this approach of, almost I call it the double infinitum loop. It never ends. You discover more as you scale things up. So we need to invent a new innovation approach to this. And that's why I actually, just in April, we launched a whole center, Societal Computing and Innovation Lab. So we can tackle this problem with everyone, and we'd love to collaborate with you on it. And here, I think partnerships become more important, and profit models change, and we talk about different trade-offs, just like you were saying. Is there a way to build things in a way that sustains and scales the open things? And we can also move those open things in science and data and AI faster into solution cycles. And as we do that, how do we actually make sure everyone wins?
So, Micah, you're doing this on the ground, trying to bring people together. Obviously, the model you mentioned, Blue Forest is embracing, is bringing beneficiaries and investors and people, various groups of people, innovators, technologies, funding, all of that to the table to make a project happen. So can you tell us how you bring these people to the table?
Yeah, absolutely. I conceive of us as really sitting between partners like the U.S. Forest Service, NGO, scientists, landowners, and also various tech forms or tech companies in various forms. And really the data at the end of the day supports these collaborations by offering a sort of common language for us to plan around, whether that actually means planning projects or whether that means planning how to engage around the benefits of those projects. And I'll give you an example of one collaboration that we have. We work really closely with the Center for Ecosystem Climate Solutions, which is led by Professor Mike Golden at UCI and Professor Roger Bales at UC Merced. And this is one of the core tools that we've used over the past years to quantify the benefits of forest restoration. And there's really two outputs from those tools that are, a lot of the outputs are great. These are the ones that we use most closely. And that is, one, the effect of thinning forest restoration on projected flame length. The reason why that's important is because generally, if you have a flame length that's over 8 feet, you're going to transition from a fire that is, let's call it beneficial. It's moving along the surface of the forest. It's doing what fires have co-evolved with the forest to do. When you get above 8 feet, generally that fire ends up in the canopy. And once a fire ends up in the canopy, that's when we end up burning down forests. So that's one really important metric for us, especially when we're working with partners on the ground like electrical utilities or water utilities that have built infrastructure in the area and they really care about their assets, or in the case of electrical utilities, liability, and need to understand what the projection for a fire is on the landscape. So that's one. The second piece is water yield increases as a result of restoration. So when you thin a forest, when you take out trees, you leave more water in the watershed. That water ends up in the streams. Those streams end up spinning hydropower, generating electricity. And we've had a lot of success engaging water agencies who own their own hydropower facilities, essentially calculating the economic benefit that they receive from these projects to drive investment. That's a good example of how we collaborate with academic and academic adjacent institutions. We've also started working really closely with Vibrant Planet, which is a tech startup and has pulled some really great academics into that startup. And we're working to build more detailed outcome-based models, both around fire risk as well as ecological outcomes like carbon, water, biodiversity. And I really think both of these partnerships are critical In the case of CEECS, the Center for Ecosystem Climate Solutions, we work really closely with Mike and Roger to further refine these outputs and to use your example of the sort of infinity loop, expand the geographic input or geographic scale of those outputs, and to ensure that we can kind of take this stacked benefit approach to new areas. And so those continuous conversations between what is needed on the ground and like what's actually possible from a technological standpoint are really critical to our collaborations and to moving that space forward.
And I think this is very essential because, for example, when you talk about forest restoration and its water benefits, you know, we don't necessarily think tons about nature as an enabler of access to resources. Well, they are the original enablers of that. And I think we also don't think much about a lot of other things that forests provide, all the other benefits. And it's easy as you know, I'm an engineer by, based on the education I have, and, you know, engineers are very, sorry, generalizing, but, you know, as a civil engineer, you're like, build a dam, you generate this much water or store this much water, or you build a pipe and it's supposed to carry this much water or that much water. And but it's very specific. You want an outcome, you build an infrastructure, it gives you what you're looking for. When it comes to nature, it's just different benefits that brings to the table. And these partners are key, because it's not one agency that benefits from this work. It's a multitude of agencies, and each one of them has a stake in this and their participation. So I think this stacking is super important, because you want to make sure they all participate in investing in these solutions, and also they can reap the benefits of that solution. So you both talked about scaling projects. Obviously, in academia, we are obsessed with generalization. We want to build one thing that can, you know, that can be, then we can apply it to so many different places. And I wonder, how do we, when it comes to these practical problems we have and practical solutions that we have to build, how does these two sides of the problem sort of come into play? And I think you sort of both touched on it, but I was wondering if you can elaborate a little bit more. Sort of, how do you balance between solution building that can be scaled and, you know, also, you know, local context very much matters, right? Like your wildfire solution in one place can totally be different from another place. So how do we sort of balance that, like scalability, generalizability, you know, local context versus broad solutions that can be applied everywhere?
So this is actually the reason we need an evaluation approach, right? That this is the reason for the infinity loop, a part of it. These are, when you go to nuanced problems, typically shrink-wrapped products don't work. You can't just have a product and scale it up for use everywhere. You know, maybe if you're building a camera and detecting, that might work. But, you know, even then, there's a lot of nuances about that. And how do you then solve a nuanced problem through a product and still evolve that product? So one example is, for instance, we built FireMap, which is now as a part of California governor's fire risk program, Fire Integrated Real-Time Information System. It's being used in every California fire through a fusion center we co-manage with Cal OES. And for California, we couple that within fire risk, the modeling and integration of data and sharing of data with an aircraft program. So the ingredients are there, the platform is there, but then when we carried it to Colorado, we needed to work with them actually in a new workflow approach. Like, what's the process of using the product? What are the data layers? What's the availabilities there? And how do you actually create a similar program with the capabilities there? This also democratizes it. In California, we built it in a way every fire chief receives this. But then when you go to other environments who are not as well resourced as California, there's still, the basics are there. The basics are openly available. And you add whatever is needed at the capacity that exists. So this, I think, creates an interesting model, because even if you had a company, and I'm a huge supporter of the fire tech industry, I think we need to grow and build a very strong industry around this, around the need. But then the model of building fire tech is different than the model of building a chatbot. Right? It could be an ingredient of it, but it should be about the problem that tech is solving, and work with practical communities and the people who actually use these products a lot more organically. So you can actually develop solutions together, not products. Products are like the byproduct of that solution.
So like both bottom up and top down when we approach these problems.
Exactly. And that's the backwards
Infinity
loops,
loop,
right?
right.
That's a lab approach. That's not like industry has these labs that actually cultivate those solutions, because when you don't know exactly how the product looks like at scale, or how it applies at scale, or it needs to be specialized, it's kind of, there's a lab approach that's partnered with public, private. NGOs have a huge role, I think, in the scale. I'll leave that description here, but we need to really put our thinking together in labs that are cross-sector.
I'll jump on the point that you made, that sort of one-size solutions, I think generally do not work when it comes to broadly the sort of ecosystem service valuation space and for wildfire. Obviously, pieces of a solution can be transferred to a new ecology or to a new geography, but it needs to still be locally adaptable. So how do we create tools that function at scale and are still able to be adapted to those local environments? So tools that are modular with adaptable frameworks. And I think that the thing that is most important is customizable outputs for local decisions. An output that may be salient to one decision maker is not the same output that may be salient to another. And I don't just mean this one needs to talk carbon, this one needs to talk water, but even aspects of each of those outputs. So I can give you a quick example of one of our projects. This was a project up in the Yuba watershed. We generally take what we call a pilot to scale approach. So we engage on a landscape, start with a small project, build relationships. Trust is critical when you're entering into a new area, and it takes time. You just need to be there. You need to work with people. So we start with smaller projects, and then our goal is to scale those projects. So the first Yuba project that we call Yuba 1 was about 15,000 acres. And based on the modeling that we did with the Center for Ecosystem Climate Solutions, we found that there was about 50,000 acre feet of water that was generated as a result of the thinning that was happening. And Yuba Water owns its own hydropower facility, and so they economically benefit from that additional water. And basically through the economic valuation that we did, we found, or they contributed about $1.5 million to that project. And in Yuba 2, that project is about 4 times the size of Yuba 1, and they've contributed about $6 million to that project. I should remember these numbers by now, but I always have to double check my sheet. And the reason why that worked fundamentally was because their board was aligned conceptually. Decision makers are really huge. And their governance and owner structure aligned with the embedded incentives that those outcomes conveyed. And by that I mean they own their infrastructure. In other examples, we haven't had success with that model because a water agency doesn't own their infrastructure. And I'm kind of overly simplifying it here. But all I mean to say is that those local contexts are really, really key. And understanding how decisions are made, what the governance structure is critical to tweaking that last 20% of the model so that they are able to inform either investment or decision making on the ground. So some of the things that I wrote down here that I think are really key: what is ownership in that landscape? Who owns what? What is the governance structure? If we're talking utility, is it publicly owned? Is it investor owned? Do they own their own hydropower production? Do they own their own transmission and distribution lines? And importantly, who needs to sign off on this, right? Who needs to use this data? And what is their appetite for uncertainty? Some people just want a number, right? We're in an academic institution. Academics love talking about uncertainty. Most people don't. They want one number that they can make a decision off of. And so I think that those are all things that My time at Blue Forest, I've learned are really critical as we're thinking about applicability of large models to local geographies.
So you brought up something super important, and I know we sort of have been talking about data and information and models while focusing on wildfires. So I was actually, maybe I go to you first, Micah, and then I'll see if Elkai can add more light to this. But how do tools, I mean, you sort of touched on this here, but like data, tools, digital tools, AI, and machine learning, how can they break down these silos, right? So it's one thing to know the decision-making process, right? There's another thing you just mentioned, like this can contribute to this much more water, right? Do we have, like, do they ask you for the tool? Do you provide them that data? How does this relationship basically evolves when it comes to using these tools to bring more people to the table, to breaking silos, to enabling permitting, all these different pieces that goes into this that are vague, right?
I think to start answering that question, maybe I'll provide a framework for how we think about data and resolution of data and the outputs from those tools. We frame it as tiers. Tier 1 is, think a data atlas. You know, we're pulling wildfire risk maps, something that you can probably access online. But for folks who don't have experience looking at GIS layers or, you know, looking at attribute tables, they want some coaching through that. Sometimes that's enough to drive a decision, or in our case, drive an investment in the landscape. Other times that's not, right? They may be very literate in GIS. They may already have access to those, and so then it falls to us to then take those outputs, do enough analysis to get to a point where they can make a decision at whatever sort of data fidelity and data resolution that they need. And sometimes that's a 2-week process, and sometimes that's a 9-month process, right? And then to the second part of your question, maybe I'll just talk through some of the innovations that I think are really interesting in the space right now, and I'll focus on the funding and financing because that's my bread and butter. But one of the challenges that we have right now is permitting. We were talking about this beforehand, right? Permitting takes a long time. We have great environmental protections in California, and as a result, it takes a long time to do any work in forest, sometimes a decade to get a project planned and permitted. So there's a lot of work just automating those processes. Honestly, most of those documents are pretty boilerplate, but they can be 200 pages long, right? So how can you speed up that process using whether it's AI or other tools? Planning is also really key, right? We have a limited amount of money for funding this sort of work. So if we have a landscape that we want to treat, and you have multiple different parties on the landscape that have sometimes symbiotic, sometimes competing interests, how do we think about where we're treating on the landscape? So there's folks like Planscape, Vibrant Planet, that are putting together these tools so you can sit down and say, this is what I care about. I care about wildfire risk around my house. I care about biodiversity. And collectively, we have $15 million to spend on this landscape. Where should we treat and how should we treat, right? Those tools are really moving that space along. And then when it comes to funding, that is where the outcome and analytical tools that thank you. Yeah. California is sort of where we sharpened our teeth, but we're working throughout the West, basically from Colorado west. We're doing some exploratory work as well in Honduras and Portugal. And to your question about the global, the scalability across the globe, about 50% of the ecosystems in the world are fire adapted. They all manifest slightly differently. They have different fire return intervals that you know, how regularly fire comes onto that landscape. And so the risk profiles on those different landscapes are different. But at the end of the day, fire is something that is this really fascinating intervention from sort of pulse from an ecosystem service, payment for ecosystem service framework. It's one of these few things where we can really clearly see what happens if you're prepared for fire, what happens if you're not prepared for fire, and what's that delta? And can we monetize that delta? So I think that there's enormous potential throughout the Western US and throughout the world for this. It becomes a question of how you create those 80% scalable tools based on the science that we know exists, and then how do we create that last 20% of those tools so that they're applied to different landscapes.
and how you carry the learnings from it back, right, to go back to that 80%. There's that backward loop there. I think I might say something shortly. The question was, how do you then turn those outputs into outcomes in a way? That's how I'm understanding. And, what are the impacts in the long term? I think, to me, that's where the nuances happen, right? The turning those impacts into really economical figures. That's what Blue Forest does really well, is that requires us to have, first of all, those prototypes, so we can actually rapidly show what could be had. Because this is like this, if you ask the communities what they need, they won't be able to come up with those, right? The way things are evolving. And how do you quickly bring things together so you can actually show them what can be had, and create demo networks and sites, right? There's a lot of demos of neat things are happening, and as we do those demos, can we also add like an impact and how it will actually compare? That's actually the hardest part of it that we can't do ourselves, right? We need others on the table, because we built a really detailed, the first of its kind, science-based prescribed fire planning tool. It's not where, it's when. What's the prescription of it? What are the conditions and what are the risks that is sort of driven by those conditions, explainable risk. So a way to communicate it is actually, you can openly burn windows, you can burn more, and here's the economic numbers that we can connect to it. So you're actually, over time, you're actually in many different ways profiting or benefiting from it. So we can't do that right now because, first of all, lots of the financial data is closed, right? There's that part of it. We don't even know how to find those. That's what I meant when we say, can we at least discover what's linkable so we can know who to go to and start having those conversations.
I have you guys, but I have someone right there. Please go ahead. Oh, you're just bringing a mic. Okay, so I think you were first.
Oh, yeah. Hi, okay. Thank you for a very crucial panel and your insightful comments. So I guess I'll say some impolitic, blunt things and then let the diplomatic people clean up the mess a little bit. And that is that I have been to the San Diego Supercomputer Center, and I have enough gray hair to remember when federal science was the king. There was an awe of federal science at a time, a long time ago. And then what has happened since is companies like Google and Meta have crushed federal science. So Google Earth Engine here in California, for example, is a premier engine, and thank goodness for Rebecca Moore and her team. And I also want to shout out to Fernando Perez and the FAIR data effort here at Berkeley. But there's a power imbalance between federal science and private enterprise right now. And Academic Conference here is trying to sort of make sense of it and be part of it. But you're not completely part of it because they're running it. And the motivations are different. So there's a role for academics, for the academic part of society to stand up because the situation is urgent.
Can I say something quick before I hand it off to you? I think it is important to realize that a lot of things that's being built at the corporate side is reliant on publicly funded data. So they cannot have any of this. If you open your weather app and you think you know what's going on today, that weather app doesn't mean anything unless NOAA actually provides that data. So it is, so as what Google is doing with flood forecasting and all that, and Meta is doing, all these entities using publicly owned data, publicly generated data, and building tools around them, which is super essential. I'm not saying it's not, but it is important to realize what is underneath it, because that is very important. Otherwise, we are not going to have the right information coming out of those tools.
Yeah, that's a great point about data. And in computing and AI, indeed, big tech is driving innovation. And, you know, they are the cool kids right now. Right? And I was just in a computing conference right before this one, and that was all the talk, you know, how do we reinvent ourselves kind of thing. But it's not, I don't see it as a threat. Actually, I see it as a big opportunity, as you said. Actually, to me, in your question, I've seen an opportunity, right? Because big tech is good about infrastructure, and the way data actually and AI is evolving, we need that type of infrastructure that needs to be brought to the table. But you know, the model of how we work together is evolving and doesn't exist at the moment at full scale. But there are examples of this. And I agree we need to open up those thinking pockets between sectors. So, and that's the societal part of it, right? Because innovation at the societal front that includes the cutting edge of science, that's actually a thing that we haven't done before at the scale that we are expected to do now. And I think a new model is emerging, and regulation is definitely becoming the bad word. Like we are hearing a lot in a bad context, but there's also maybe in this space, we need to think of maybe we want not regulation, but like some rules of engagement. And how do we then bring those thinking minds together? Because there are good examples of it. I don't want to single out one big tech, because I think they're all contributing in different ways. So I'm not going to give examples. But in the fire domain, there is actually quite good influences in climate tech also. And it could be a funder of innovation and sustainer of innovation as well. So yeah, what is the constructive thing to do here? And start talking to each other. That's really the billions of dollars worth question.
You had a question.
Yes, if I could have a microphone.
We do just real quick.
Yes.
People from lunch, so
Yes, yes.
Yes, I'll try not to hold up lunch. I'm Alex Bell. I'm the Associate Director of the Baker Climate Ingenuity Hub. So it's been a very interesting discussion, because you can see technical, political, economic elements all coming together, not necessarily working together. If I ask, you know, what's the objective? The objective is for California and other communities to have a recognition of what fire can do, especially urban forest fires, which we've seen a lot of recently, how the climate can impact that, what the economic impact is when you've had a fire, we know that from experience, how to bring this all together with public policy so that looking forward, you try to set up a system that does minimal damage to the environment, to the economy, and to people. Now, what's the limitation? Is it the amount of data? Is it politics? Is it different entities working together?
All of it. All of the above.
All of the above. Yeah, that's what I was afraid was going to be the answer. Yeah. But how do you work effectively? How do we work effectively as a community to, you know, achieve the goal that I articulated?
Yeah, go ahead. Go ahead. I think Micah sort of touched on that, but I
Yeah.
think.
Please jump in. So the part of what I didn't say before in my answer was, what is big tech maybe not good at? The nuances. Right? You can't just, you can definitely use a hammer to put a nail on the wall, and you can use a truck.
Right.
But you can't go at it with a truck without damaging the wall, right? So that's like that. Actually, the nuances come from science and practice. And how do we actually create that innovation cycle that includes that? Right? That's, everything is limiting, but if you focus at a nuanced solution, you can suddenly solve it. But we need to have the right people on the table and with the culture to accept those nuances. And that's the harder part of it, I think, building that culture of, acknowledging
Cultural attitudes.
trade-offs.
I answered this question a few different ways in my head, so I'll see how it comes out now. But I think that at the end of the day, it's about open communication. Wildfire is a really interesting phenomenon because it's the sort of thing that affects everyone and affects people across political spectrums. Nobody wants their house to burn down. Everybody is worried about the effect of fire. And as a result, it's been really fascinating experience for me to work in purple and red counties, largely in rural areas, and see how fire as a flashpoint enables groups from with different political ideologies, different approaches to life, different beliefs in climate change to circle around this one issue. And I think that everybody always says we need to communicate more, we need to understand the underlying drivers of different groups of people, and that is absolutely true in this space. And I think that this provides a really unique opportunity, actually, to bring together these different groups of folks, understand how and why they care about this space, and figure out how to put together solutions together. So in a weird way, wildfire is one of the few things that I'm politically optimistic about.
And I'll just say one thing, and then I think maybe you can ask your question later around lunch. I think we have organized ourselves around resource availability and resource management in the past century. And I guess this is a different time. We are organizing ourselves around hazards and impacts, which is a totally different business model. I didn't get to that question. I had that question in the list. So it's kind of like you have to really rethink how you do things. You have to actually bring different kind of people together, because all these resource managers think within their own boundaries or their business model and the money they have. So kind of like you have to shift it, right? Okay, so we have gone over. This was a great conversation. I really appreciate both of you
Thanks for
for
having
bringing
us.
so much context and value into this very complex issue and communicating it so nicely. And with that, I think, Sarah, I hand it off to you.